Hello, students. I have planned to record this video to help you with this lab, that is Digital Integrated Circuits Design Lab. So we have here two sections, Part A, Part B. Part B. In Part A, we're supposed to be using Verilog HDL, and in Part B, we're supposed to be using the circuits, CMOS circuits. So before we start with any of these programs, so let us go to the required softwares. What you have to do is just type in your browser Model Sim Intel Starter Edition. So the very first link that you see here, Model Sim Intel FPGAs Standard Edition software, open in this in new tab. So you will get here the simulation tools, Model Sim Intel FPGA standard and version 18.1. So here there is a drop down menu here. Click there, select this latest. Now ensure that here standard is there here, because if you click here, Pro is there, and this standard is Questa standard, but we need Model Sim standard. Okay, go with Model Sim Intel FPGA standard. Okay, then scroll it down here. We have two sections here. One is for Linux software, the other is for Windows software. Click on Windows software and then click on this download. So once this executable file is downloaded, just double click the way you install VLC player, just like that. This installation procedure is okay. So that's how you have to download this required software. And the other software required is this LT Spice. In your browser, again, type this LT Spice download for Windows. Then the very first link, open link in new tab. Here, you will see under this download LT Spice, this version 24.0.12. This is the latest version. And in lab, we have used this version. Okay. So since you are you practiced in the lab this version, so it is better. It is recommended to download this one. Though I will demonstrate both of this, I recommend you to download what you people have done in the lab. That is this version. Okay. Then once this is downloaded, then this is also like very easy to install. This is also exe file. So just double click and next. So installation will be done. Okay. Once you have downloaded and then installed on your desktop, you will be seeing this shortcut icon like this for Model Sim and shortcut icon for LT Spice. That lab version. In lab, what we have used, this is the version. This one is the latest one. So both I will be demonstrating. I recommend you to go with this version that is in the lab, whatever you people have done, that version only you download. Okay. Now, coming to the discussion here, we have this 1-bit experiment one is this 1-bit full adder using 2 half adders. So let's see that. So to develop 1-bit full adder, using 2 half adders. Okay. 2 half adders. This is how the block diagram is. This is a full adder having A, B, C in inputs and having some carry out outputs. Inside, let's say we have one half adder, one, another half adder. This is half adder two. So first half adder will take this A and B as inputs. It will produce sum one and a carry one. This sum one will go as the input to the second half adder, and this C in will go as the input to the second half adder. From second half adder, whatever the sum, you get again sum here, and let's call that sum as S2, and this is C. So this S2 will go directly to this sum. But this C1 and C2 will go through this OR gate. So here, this C1 and this C2. And the output of this OR gate is what going to this CO. So that's how the structure of a full add, one bit full adder using two half adders. So now the question is how we can develop the half adder itself. So to develop the half adder, what is required is we need one XOR gate and one AND gate. So here AB and this same A and same B will be going to this AND gate, and this XOR gate will produce sum, and this AND gate will produce CO. So we know the internal logic of this block diagram, half adder block diagram. Internal logic is one XOR gate is there, one AND gate is there. So now we have to develop the Verilog code for this and Verilog code for this OR gate. That's all. So we don't need to develop the OR gate Verilog code. We can make use of the primitive here. Verilog HDL has got keywords direct like XOR, XNOR, and or like that. So those are called primitives. Then these primitives we can use. Here the primitive required is OR gate. This OR keyword is required. So let's see how we are going to develop. So module half adder is HA, and it has got A comma B comma sum comma C. These are the port list. And here port type input A comma B, put the semicolon. Now output sum comma CO, put the semicolon. Now what is required? XOR gate is required. Use this XOR keyword. The syntax is open the parenthesis. Now first output variable should come. So what is that it is going to produce XOR gate? XOR gate is going to produce sum. What inputs it is going to take? A and B. So here sum is kept first, sum variable, and then followed by that input variables. And then close the parenthesis, terminate with a semicolon. And we need AND gate also. So we have AND keyword. This is a primitive. Syntax is again open the parenthesis. First output variable, that is CO, followed by that input variables, A comma B. Now this module needs to be ended with the AND module. So kindly remember here, you cannot write AND space module. You're supposed to be writing AND module without space. Okay. So, and also remember there is no semicolon. Okay. So that's how this half adder code is written. Now, what we have to do is we have to instantiate this half adder twice. What is that? Instantiate. Instantiate. So we have to instantiate. That is something, but we have to call this half adder. How many times? Twice we have to call here. So let us see how we call that. In full adder we have to call. So we start writing a code for full adder. Audio. FA full adder. Full adder has got inputs A comma, B comma, C in comma, sum comma, CO. And remember here we have to terminate with a semicolon. Now the type declaration. So input is a keyword lowercase, input space A comma, B comma, C in semicolon. This is the semicolon. And then output. Here sum comma, CO, then semicolon. Here it is A comma, B comma, C in comma, semicolon. Okay. Now, two times we have to instantiate that half adder. So how to instantiate means with the name, this HA, and then one instantiation name. So like this HA space instantiation name, some name you have to give. Let's call it as a DUD, not DUD. HA INS1 in instance 1. So what we have to pass for the first half adder, we have to pass this A and B, and what it gives S1 and C. Now next what we have to do one more time, we have to instantiate. So instantiation name, I am giving INS2. So what I am passing to this as the inputs, this S1, S1, comma, C in. So what I am getting here, sum and C2. So now what I have to do next, this sum is what directly gone to this sum, right? So directly instead of writing this S2, we can write sum. So that's what we did here. This one. Now coming to this producing this CO carry out, so we have to use this OR gate. So OR gate will take this C1 and C2 as inputs. So let us put the keyword OR. Now the syntax is open the parenthesis, first output variable. So output variable is CO, followed by that input variable, C1 comes C2. Now this module needs to be closed with the AND module. Okay. Now what we have to do, we have written this code. This is called design file. Design file of what? Full adder. So this file name, let us give fa.p. Now we have to write a test bench. So to write the test bench, Test bench also starts with the module. Now, test bench recommended name is TB underscore whatever the module that you are going to test. Now, all input variables here, all input variables will become reg and all output variables will become y. So here, reg a comma b comma c in, and this output variables y sum comma co. Now here we have to call the module that you wanted to test. What is the module that you wanted to test? Wanted to test this module, right? The way we have called HA. So similarly, we have to call this one. So that is FA space instance 3. Or you can put here DUT. DUT stands for design under test. So this is the design that we are testing. So instead of INS3, we also can write design under test. That is DUT. So let's go with INS3, that is instance 3. A comma, B comma, C in comma, sum comma, CO. This order is must away here. You cannot write here in a different way. The way they are, the variables in similar order, they must be wherever you are calling them. Okay. Next is we have to apply some inputs now. We have to generate inputs so that those inputs can be applied to this A, B, C, N. So to generate input variables, input test vectors, initial, begin. So we can use the loop here for loop. And you can write here I equal to 0, I less than or equal to 7, I equal to I plus 1. Then begin. Here we want to use concatenation operator and A comma B comma C in. We are tying all this together with the help of this concatenation operator and applying this I value, assigning this I value to this ABC. So what happens is, let's say A comma B comma C in. The moment when I value is 5, it means internally is 5 in binary format 101. So this 1 will be assigned to this C in, this 0 will be assigned to this B, this 1 will be assigned to A. That's how it is. Now, once that is done, you have to give some delay and then this begin end. And then this begin end also required. Before that, what we do is you give some delay and then stop. Dollar stop is a system function, system task. We have uh, system tasks and system functions. So the other time is a system function. System function means it returns some value, whereas system task will not return any value. It only may help us to stop the simulation at this point. Next is after that this begin end is done here. Here this. Now After that, this module needs to be enclosed with the end module. Okay. We'll see with the simulation